This is Families of Functions Part 1, and today we're going to talk about, we already did recognizing graphs of common functions. We did that in class. We did horizontal shifts in class. Today we're going to do number 2, which is use vertical shifts to graph functions, and we're going to do number 4, which is use reflections to graph functions. And then in Part 2 we will do the rest of it. So let's look. And you unfortunately don't have these notes. We're going to start with vertical shifts. So we'll call this just vertical shifts. And they do exactly what you think. They shift things vertically, up and down. Vertical is up and down. And so if you have a function, and I'm going to give you this funky form again, y equals f of x plus c, or y equals f of x minus c. And we talked about this in class where we had that funky function for horizontal shifts where it was plus and minus c on the inside of the parentheses, and now the plus and minus c are on the outside of the parentheses. This will do a vertical shift. And unlike horizontal, the plus and the minus go opposite ways. In vertical, when the plus or minus c, remember these are outside. We consider outside the parentheses or outside the function. Now they do exactly what you would think. Plus c goes up c units. And minus c goes down. Oops, spelled down wrong. Down c units. So let's look at a graph. We'll call this example 1. Let's take a look at, or we're going to use f of x equals the absolute value of x, so we're going to graph it, to find, using vertical shifts, f of x equals absolute value of x minus 4. So we're going to draw a graph. And we know the absolute value graph is a v. So we're going to draw in the parent function first. You would have a point at 0, 0, 1, 1, negative 1, 1. And I didn't draw my points in very good. Probably should have drew my points first. Let's redo that. Let's do it right. You've got 0, 0, 1, 1, negative 1, 1. And we know the shape is a V, so we'll draw the V. That is f of x equals the absolute value of x. And we're going to do minus 4 now on the outside. So that is a vertical shift down 4. So we're going to take these 3 points that we graphed, that's on all absolute value graphs. So we're going to move each one down 4. So there'll be one there, there'll be one right there, and one right there. And we'll draw our V again. And that is f of x equals the absolute value of x minus 4. So again, on your homework, when we do it, I want you to draw the parent function, and I want you to draw the vertical shift. Okay, let's do another example. Let's do example 2. And remember, it doesn't always work for just one of the function, families of functions. It works for all. These vertical shift works for all of them. So it doesn't matter which family we have, which group we have, whether it's square root or absolute value or squared or cubed. These shifts, the vertical shifts, work the same way. So if I want to use f of x equals, let's do x cubed. Let's do f of x equals x cubed to graph f of x equal to x cubed plus 3. We're going to start with the parent function f of x equals x cubed, and we're going to graph that. And I said, or I don't know if I told all the classes, but I said to most of them, you're going to want to graph 3 numbers here. You're going to graph -1, 0, and 1. That's the key numbers for all of the graphs except for square root, because we can't do negative. So we're going to graph -1, 0, and 1 for f of x equals x squared. Let's get this thing right. Or x cubed, sorry, x cubed. So it's a -1, 1 on, or -1, -1 for x cubed, and we got a 0, 0, and a 1, 1. So there's my 3 points. And x cubed is more of a vertical s, so it goes down, turns through 0, 0, and then turns up. So that's f of x equals x cubed. And now we're going to do x cubed plus 3, so we're going to move up 3. Each one will move up 3. And I'll do this in a different color. Hopefully it shows up online. So instead of being at -1, -1, we're going to move up 3. We'll be 1, 2, 3. We'll be at -1, 2. Instead of being at 0, 0, we'll be at 0, 3. And instead of being at 1, 1, we'll be at 1, 4. And it'll still turn down, turn across, and go up. So everything just moved up 3 units. And we've got this one labeled as f of x equals x cubed plus 3. So that's vertical shifts. If you add, it goes up. If you subtract, it goes down. Horizontal shifts we did in class. So that would have been the next page in your notes. What we have now is reflections over the x. So we're going to have to make our own note sheet here, do over the x. So let's maybe add another page. Hold on here. Not that. That. There we go. All right.
Christian Perez, please
We're going to do.
report to the office. Christian Perez, please report to the office.
Sorry about that. I'm doing this at school. Reflections. And it's called reflections. And they call it in the book about. So if you ever hear the word about, it really means over. About the y. I'm sorry, this one we're doing is about the x-axis. So reflections over the x-axis or about the x-axis. That is when the negative is out front of the function. So if, in general, if you have y equals negative f of x, so f of x would be our function, whatever it is, x squared, cube root, square root, absolute value, any of those, the negative would be out in front. If that happens, then it is reflected over the x-axis. So let's look at an example. I think we're on example 3. Oops. Can't do the problem without writing it down what it is first. Example 3. We're going to do use f of x equals the cube root of x to graph f of x equals negative cube root of x. And that's supposed to be cube root, so that's a 3. Okay, cube root of x. To do cube root, that is more of a flattened s. And it is going to be negative 1, 0, and 1 that we're going to graph. It's negative 1, 0, 0, and 1, 1. And it's more of a flatten. It flattens out and then turns and flattens out again. So there's our f of x. That's our f of x equal to cube root of x. That's our parent function. And we're going to do negative cube root of x. So we're going to flip it over the x-axis. So let me go to a different color here. And 0, 0 is going to stay the same. If it's on the x-axis, it's going to stay the same place. But this point up here at 1, 1, if it flips over the x-axis, it's going to flip to 1, negative 1. And the point negative 1, negative 1, if it flips over the x-axis, it's going to flip up. And what you get is now it turns the other way, and you get this little x-looking figure, but this would be f of x equals negative cube root of x. And again, it can work for any of the functions. They will all flip over the x-axis. Let's look what happens when we have a negative inside. So it is on, in your notes, you have, it's page, what page is it? Page 5 in your notes, which is really the third page. Is this reflection over the y-axis, and we got the negative in the inside of the function, and that when the negative's on the inside, that means the reflection goes over the y. It reflects horizontally. And so if we're going to use the graph of f of x equals the square root of x to obtain the graph of f of x equals negative square root of x, we would graph the square root of x first. So you do square root's a special one. You've got, instead of doing negative 1, 0, and 1, we're going to do 0, we're going to do 1, and 4, 3, 4, and 2. Okay, there is my f of x parent function. F of x equals the square root of x. And if we're reflecting it over the y-axis, so 0, 0 is not going to change. I'll do this in blue. So 0, 0 is going to change. Not going to change. But 1, 1 will become, if we change it over the y-axis, it will become negative 1, 1. And 4, 2 will become negative 4, 2. And there is f of x equals square root of a negative x. Try the checkpoint. When you come back, I'll give you the answer, or I'll show you the answer. Okay. To do cube root of x, we've got 0, 0, 1, 1, negative 1, 1. Cube root of x is more of a flattened s, remember? So this is f of x equals the cube root of x. And if we flip this point, which is at 1, 1, let me change to black here. It would flip it from 1, 1, we would flip it to negative 1, 1. And 0, 0 stays the same. And negative 1 would flip to positive 1, negative 1. And what you get is pretty much that same x that we got on the last example, or on the example 4. Or 3, I think, actually. Whatever it was on the last page. We get that same example. Or we get that same x. So we got f of x equals cube root of negative x. It just works out that way because this thing is balanced on both sides of this. It's got one here and it's reflected kind of here anyways. So when you reflect either way, you get the same figure. But again, you would reflect different things. If it's cube root, it's different. It's still reflected over the y-axis. If it's squared, it's still reflected over the y-axis, which you would get the same graph. If it's cubed, it's still reflected over the y-axis. That's all we're going to do today for notes. So this is all for part 1. I will have notes for part 2 for you tomorrow night. You will get your homework assignment in class.